Welcome to a quick tutorial for using TreeTools Realtime for analysing your drone imagery for the purposes of creating virtual forest inventories. In this particular case, I've got some drone imagery that I've collected on the left-hand side. Just opening up one of those files, you can see that this is a post-thinning, waste thinning operation, and wanting to use this imagery to create virtual plots for the evaluation of stocking by using AI tree detection models. So what we can do is use TreeTools Realtime Inventory. When you download TreeTools from the internet, you'll find that it's just an application file here. Double-clicking on that file will result in this interface appearing. What we can do is set the initial parameters, in this case usually some reference to the forest compartmental stand and a particular job number that might be being undertaken. We can also set in the assumed flight parameters. So in this case here, I flew my drone at 120 meters above the ground level using a terrain following flight. And select the AI model that we're intending to use as well. So in this case here, we're going to choose a post-thinning model. We can also set the estimated tree height, just plus or minus 5 meters is fine, and this just increases the accuracy of the AI detection. We can then go through and choose one of three workflows to evaluate the stocking. Image processing, which is what I'm going to cover today, and we can also look at processing videos directly from the drone, and of course we can actually live stream real-time video directly from the drone and processing stocking results while the drone is still flying. Today I'm just going to focus on the image processing just to get you started. Selecting image processing, I've got the option here to select a digital terrain model if applicable or needed. In this case here, I did fly a terrain flight at 120 meters, so I'm comfortable that I'm going to process these images without introducing an additional terrain model to the dataset. So we can select that folder. We'll select the example 1 folder here, choose that folder, and we're ready to go. I'm just going to jump into that folder just so you can see how that imagery gets processed as we analyze it. So just choose go. As you can see, each of the images has come up on the right hand side here with a detection: 423 trees per hectare, 44 stems collected in each of those plots. And as you can see on the left hand side, each of those images are being processed to a virtual plot. We've also got 3 additional files are created as well, and that's a KMZ file for loading into Google Earth. We've got a results file and a summary. Just having a look at some of these files in a bit more detail, you can see that we've got our virtual plot has been put in place. This is the yellow circular perimeter indicating the plot boundary. We can see each of the tree detections with the red bounding blocks. A tree is determined as being inside the plot if half its canopy is within the plot boundary, and that has resulted in 58 trees being detected in that 0.118 hectare plot with a radius of 19.4 meters. And each of those trees, those 58 trees detected, have got a respective tree frequency of accounting for 8.5 stems per hectare, which is resulting in 491 trees per hectare being represented by that plot sample. We can see a summary of those results in the CSV file here. And so this gives us not only the locations of all of those virtual plots, but we can also see the date and time at which they were collected, and also the trees per hectare in each one of those images, together with a whole range of other parameters associated with that particular inventory. We also get a summary file as well, And so that summary file then brings together those 11 images that were collected, gives us an average tree count of 51 trees detected per plot, with a average stocking therefore of 434 stems per hectare, together with a PLE, which is of course the 95% confidence interval over the mean of 8.9%. There's an additional parameter there which is included with an estimate of the number of plots to reach a 10% PLE. So if it was a highly variable block and your PLE was higher than 10%, that would give you an indicator of how many more plots you need to go and measure to get it below that confidence level. Hopefully that's given you a little bit of an insight into using TreeTools Realtime. There are two additional features to the software, that is processing videos, where we can actually select a video file to process, and we can actually set up a live stream directly with the drone controller and process real-time stockings while the drone's actually in the air as well. But this will get you started, and look forward to your feedback.